Okay, we're switching gears just a little bit, going on to solving exponential and logarithmic inequalities. Today's focus is going to be on the graphing portion, and tomorrow's focus is going to be more on the algebra portion. I've preloaded all of the graphs for you just to make the video a little bit shorter. So please make sure that you're getting caught up in this from both copying the notes down into your notes, but more importantly, get into the habit of putting this into your calculator so you can actually see what's going on. That way, if your screen isn't matching, we can talk about how to get your screen to match up by tomorrow so that you understand what you're looking at. This is Y1 and that's Y2. Okay, so now what we're going to do here is we're going to first identify the point where these two parts intersect each other. And remember that second trace, number 5, enter, enter, enter. You're looking for that intersection point. The intersection point here is 1.39 and 0. Now, after we've done that, we've got to determine what is actually going on here. So let's interpret what this algebra says. This algebra says when is the exponential line, that's the curve, greater than 0. So now what I'll do is I'll go ahead and fill that in by using the highlighter. I'm looking for the portion of the graph which is in this highlighted area here. That highlighted area begins at the intersection point 1.39. It continues on and on to positive infinity because this part of the line will not reach an asymptote. We'll talk about asymptotes and how they affect our answer in some more examples moving forward. So that means the answer is x is greater than 1.39. Now let's go to the table version and see if we can determine where that occurs so that you guys can start looking at tables and determine your answers from just tables. So I've got negative, which is less than 0, negative, which is less than 0, negative, which is less than 0, positive, which is greater than 0. What that means is that between the values of 1 and 2, the answer occurs. That's a very important thing to understand, especially if it says what is the estimated answer to this problem. So I could say the estimated answer to this problem lies somewhere between 1 and 2 because that is the place where the y values for the exponential graph get greater than the y values for the horizontal line y equals 0. Alright, likewise, number 2 shows this situation here. We'll begin by determining this point of intersection, which is 2.46 and 5. This is y1, that's y2, second trace, intersect to find that point. Okay? Now we've got to interpret what the algebra is telling us. This time, the algebra is telling us when is the curved exponential line less than or equal to 5. Well, that occurs inside of this highlighted area here. So now we've got to determine what that is. That becomes all numbers less than or equal to 2.46. Now, although there's an asymptote here, this asymptote does not affect the x values. That's why we have no restriction on the left side. You'll see when we get to logarithms in just a minute that that actually occurs. Okay, let's use our table to determine where the answer is approximately situated. 1 is less than 5, 3 is less than 5, but 9 is greater than 5. So that means that the answer occurs between the values of 2 and 3. So be able to read from a table so that you can understand where the solution actually is. Because you will have questions like question number 3 on your assessment. So please take a few minutes now to determine where the solution is. If you need more time, then please pause the video before moving on so that you have the practice that it takes in order to determine this answer. Alright, the first thing we're going to do is interpret where the first answer 3 to the p plus 2, that's going to be y1, is greater than 8 to the 3p power. Okay? So let's see. That's going to be less than, greater than, greater than, greater than, greater than, greater than, and now all of a sudden it becomes less than. So the change occurs between the values of 0 and 1. Okay? Now from that information, we've got to be able to create a solution. So that means that I'm looking for the place where this one is greater than that one. I notice that 9 is greater than 1 and 27 is less than 512. Okay, so I'm going to estimate about 1/2. Okay, I'm going to say at about 1/2, halfway between 0 and 1, the change occurs. Before I get to 1/2, y1 is greater than y2. So that means that my solution is going to occur for all values of x that are less than or equal to 1/2. So be very careful about this so you can see it. If you need confirmation that this is occurring, just go back in and graph these two functions and take a look at what's actually going on there. Okay? All right, moving on. Number 4, 5, and 6 deal with logarithms. You'll notice I've already preloaded the graphs and made them separate colors and labeled each one, because that's going to be very important that you're clear in your mind which one is which when you're actually solving these problems. Now let's interpret what's actually happening here. When is 10x plus 1, in this case that's the black line, less than 16x plus, or 16 plus 6x, that's the red line. So what we're going to do is we're going to shade below the red line. So we're looking for the solution to be in this region right here. Okay? Now there's some important things to consider here. First of all, the x values do not continue on and on and on to negative infinity, because now all of a sudden there is an asymptote located approximately here. All right? Much like other functions, such as the square root function, which have a definite beginning, we have a restriction on the solution to this problem. Okay? So you have to consider that very carefully before we actually move on from this question. So the first thing, again, that we have to determine is that intersection point right there. By graphing this and determining that, we will get 1.5 and 2. That means that our answer is going to occur somewhere around 1.5. Okay? Now, the black line is below the red line when we are less than 1.5. Now we've got to figure out the place where this graph right here stops moving to the left. It stops moving to the left at this place right here. When the argument equals 0, that is when we have our restriction. Okay? So much like when you have a restriction in the denominator of a rational function, we simply say, okay, 10x plus 1 equals 0. Once we find that place, we have found the other side of the restriction. So I'm going to subtract 1 to both sides, and I get 10x equals negative 1 divided by 10. So the restriction occurs here at negative 1/10. The solution to this problem is all values of x between negative 1/10 and 1.5. All right, number 5, we're going to first highlight the area that we need here. When is 3x minus 5 greater than x plus 7? So that means we need the area that is going to be above the red line. We're going to look in this region here for our solution. Likewise, as before, we're going to identify what our intersection point is, and that's 6 and 2 and 2/3, or 2 1/3. All right, and then we're going to determine when the black line is above the red line. This time, the black line is above the red line when x is greater than or equal to 6. Now, because we are going to the right, there is no asymptote on the x values to the right on this particular graph, so we do not need to include the restriction that we have included in question number 4. Question number 6, again, we've got to first identify our shaded region. So our shaded region is going to be when this 2x plus 1 is less than 3x minus 2. So we're going to go ahead and identify that region by shading below the red line, because the red line is 3x minus 2. The next thing we're going to do is identify that intersection point. It is identified as 2, 1. Once we've identified that, now we need to identify where the solution occurs. Okay? Since we need to know when the black line is in the highlighted region, that is going to be when x is greater than 2. Again, there's no asymptote when moving to the right on this particular graph, so we do not need to include the restriction that we included in number 4. Question number 7. Question number 7 is a set of table values for this logarithm. We need to know when that is greater than or equal to 1. Well, that occurs, whoops, highlight please, that occurs at the number 9. Okay? So we are going to fill that in as x being greater than or equal to 9. Because the values of this are getting greater and not approaching an asymptote, we do not need to worry about the other side of the restriction. Please make sure that you have any clarifying questions ready to ask at the beginning of class tomorrow. I realize that some of these problems involving the logarithms can be a little bit confusing, so just make sure that you ask any questions that you might have.